This is the Math 2 Chapter 3 review from pages 195 to 192 in your book. We're just going to work through these 8 sections of problems that you find in the back. So, first up we have RSTUV congruent to KLMNO, and we need to complete our following statements, particularly looking at the corresponding parts. So, if we look at TS, and TS is in that first shape, whatever it may be. ST, TS, same thing. We're going to match up the corresponding parts. So T is the third letter, S is the second. So in the other object, we would just call it ML, because M is the third, L is the second. For number 2, we need to find angle N. Angle N is the fourth letter in our second object. So we want to match to the fourth letter there. That's going to be angle U. LM would be second, third letter. Second, third letter would be ST. Then VUTSR actually goes in the reverse order as the original name, so we're just going to reverse the order. The other ones say ONMLK. Okay, now we look down. At 5 through 8, we're going to match up corresponding parts. So angle P is corresponding in the name to W. So the measure of angle W is 80, so P will be the same thing. QR are the second, third letters, so it's going to be corresponding to XY. XY is 3, so QR is 3. WX is the first, second letter. That's going to match to PQ, so that'll be 5. Measure of angle Z, that's corresponding to S, so that's 35. The measure of angle X is corresponding to Q, so that's 100. And the measure of angle R is going to be 145 degrees, because that's corresponding to Y. In number 11, we need to figure out what angle is included between DH and DF. The way we can figure out the angle that's included is usually look at the letter they have in common. If I look at those, DH and DF, they both have angle letter D, so we say angle D. Now if we drew this out though, just to check, we have DH right here, we have DF right there, so the angle D would be the angle between it. Now, the side included between M and R, well, that kind of follows the same idea as above. It's going to be the side made of those letters. So that's going to be MR if we drew OMR. Okay, for number 13, which postulator theorem would we use to show that they are congruent? Now, in 13, I have those two sides, but I also have a reflexive property there. Now by that reflexive property, I have two sides. I don't have an angle, so that's going to be not enough information, or we'll just put none. For 14, we're looking, we have an angle, we have a side, nothing else, so that one's going to be none as well. But if we look at 15, we have two sets of sides, and then we have the vertical angles. Now by the vertical angles, that gives us an angle pair, so this will be side, angle, side. Now in number 16, we think of this as a mirror image if you just reflect one onto the other, and that's going to be an angle, angle, side congruence. For number 17, how can we use congruent triangles to prove the statement is true? So I need to find a way the triangles are congruent. The way the two triangles are congruent is going to be by two angles and a side. Now the side is right here. It is not between the two angles. So I would show they're congruent by angle, angle, side, and then I would then show that TV is congruent to YW by CP, CTC. For number 18, we look at our two given angle pairs. We have reflexive property right here. Once we have reflexive property, we now have angle, side, angle congruence, and then BE is congruent to DE by CP, CTC. For number 19, I have two sets of sides, and then I have the reflexive. Then my two triangles are congruent by side, side, side. And the last angle B is congruent to angle D because corresponding parts of congruent triangles are congruent. Number 20, I have two sets of sides, or one set of side. I have the reflexive on KM, and then I got these parallel lines, and that's what those arrows mean. Whenever we see parallel lines, we're going to look for alternate interior angles, which I actually have right there. So KM is the transversal, line KL and M are our parallel lines. Here's our parallel here and here. So by our transversal, we get the alternate interior angles. So now I'm looking at a side angle side congruence. Two sets of sides, one set of angles, and the angle is between the sides. And then the Kn is congruent to ML by CPCTC, which once again means corresponding parts of congruent triangles are congruent. For number 21, we need to find x and y. Now, since it is an isosceles triangle, I know that x will be 4. And now looking at the angles on the inside, since angle y is one of the two base angles, so I know that is congruent. I can say they're both y. So that's 50 plus 2 y's equals 180. That's 2y equals 130, so y equals 65. Now for 22, I know that x is going to be the supplement to 125. So that's going to be 55 degrees. Now it's also vertical to the angle inside the triangle with y. And let's just redraw that over here and just rotate it around. So I got 55. Those two sides congruent, so that is an isosceles. And I have y there. Well, that means this one is also y because it is isosceles and those are my base angles. So 180 equals 55 plus 2y. That's 125 equals 2y. And so y comes out to be 62.5. Okay, we're moving over now to 23. I can figure out first angle y. Because the angles are bisected and they're at the 25, I know that angle y is going to be 90 degrees because it is perpendicular. Then once I have those right angles, I can go 25, 90, and x adds to 180. You could also say, well, if it's x plus 25 equals 90, because we know those two have to add up to 90, and so we get x is 65 degrees. For 24, this is an equilateral triangle, means it's also equiangular. Equilateral means x is also 7, since all the sides are the same. And y is going to be 60, because if it's equiangular, all the angles are the same. So you could say 3y equals 180, and again, y is 60. Anytime it's equiangular, all the angles are 60 degrees. Number 25, we need to write the proof, so we're going to start with our givens. We have Ln is perpendicular to Km, and KL is perpendicular to ML. Make sure we put given there. Okay, now let's look. We got that Ln is congruent to itself. That is reflexive property. That is a pretty easy one, so let's get that one down and taken care of. Put our congruence there. Now I have that right angle at N, so let's from that now say that angle LNK and L and M are right angles. And we got that because it was given perpendicular, so that's the definition of perpendicular. Now, if they're right angles, then that means that triangle LNK and triangle LNM are right triangles. and that's the definition of a right triangle, which gets us to what we want at the very end. At the very end, we want KLN, just another name for L and K, KLN, congruent to MLN. And the reason that works is because we have right triangles where the hypotenuses are congruent and one set of the legs are congruent at LN. So this is going to be a congruence by hypotenuse leg. Do not write this one as being side-side angle. That never works. So it's got right angles, so it's going to be hypotenuse leg. Now for 26, we're going to start with the same thing. PS is perpendicular to SQ, and RQ is perpendicular to QS. Those are both given. And then PQ is perpendicular to R, or concurrent to RS. So it's marked, that's marked. Now, because these are both perpendicular, we then can say that angle PSQ and angle RQS are right angles. And then, if they're right angles, we can say that PSQ and RQS are right triangles. Now, we got that first one, or that previous step, by the definition of perpendicular lines. The next one is the definition of right angles, or right triangles, we should say, right triangles. So now we have right triangles. We have the side PQ and RS. We also have that QS is congruent to QS by reflexive property. So now when looking at it, we have two sets of sides and an angle. So I know that PSQ and RQS are congruent. And the reason is, like the one before, is hypotenuse leg. So because the right triangles, where the hypotenuses, PQ and RS, are congruent, and the one set of legs, QS and QS, are congruent, we have hypotenuse leg. And we get that from this step, and this one. Now, if you didn't want to write that as a flowchart proof, you could have written it as a 2-column proof, as I did in number 25. You'd have line 1, 2, 3, 4, 5, 6, and then 7. For number 27, now we need to separate this into two triangles. Now, if I look at what's labeled right here, they actually have some overlap. So I'm going to make it triangle AEC and triangle ADB. So I'm going to draw them over here and kind of work with them, see what I can get. So those are the two triangles I have. I have that AE and AB are congruent. AD, AC are congruent, and then the angles at A, although they're not the same angle by reflexive, it is given that they are congruent. So this looks like a congruence of side, angle, side, and that's going to be triangle AEC is congruent to triangle A. Let's see, we went from A to E, that went down the two marking side, so that'd be A to B, D. Now for 28, we're going to separate them. And I have F, I, H, I, H, G. I have congruent sides here, right angles, and then the reflexive side is IH, which is right there. So now looking at this, I do have right angles. That does not mean, though, necessarily it's hypotenuse leg, because in this case it's both of the legs. So it's not leg theorem. It's going to be side, angle, side. And I could go triangle FIH is congruent to triangle corresponding to F is G, the correspond to the right angle in the first triangle, which was I, is going to be H, and it figures out with I. So FIH in triangle GHI. For number 29, I'm going to draw this triangle here that's shaded, and then I'm going to draw this triangle. So I have PTS, which has those markings, RAT, which has those. Now, we look for another congruence because we only got an angle on a side. I actually have a reflexive property right here at angle T. So that's going to be an angle, side, angle, triangle TSP for the top. So I went from the three-lined to the single angle to the non-marked angle. On the bottom one, that would be TAR. For number 30, we need to identify the congruence transformation. We have a couple different options. The first thing I could do is rotate 90 degrees counterclockwise, which would put it down here. So that would be rotate 90 degrees counterclockwise. Then I'm going to reflect across the y-axis, and that would swing it over. So L would map to X, N would map to Z, M would map to Y. So those would be my two steps for one way. Another way I see it is I could have rotated 90 degrees clockwise. And then by doing that, it would put me here with L prime, M prime, N prime. And then I would translate down, not translate, I would reflect over the x-axis to match L to X, N to Z, and M to Y, which if we look at the names, M and Y should be corresponding, L and X should be corresponding, N and Z would be corresponding. So either of those would be an example. Rotate one way, reflect across the axis. Now for 31, we're looking at different ways we can transform P to get to D. One way I see is if we put a point right in the middle of the two, we could rotate 180 degrees in either direction to get it to map onto D. If we translated it, so let's think on this little point right here, on point P, translated it to right here. So we could translate, then rotate 180. That would be another option. We could reflect across the axis, which would then give us something along the lines of this, and then we could cut that across this middle line in between the two, and then reflect it up to match onto there. So that could be two reflections from there. So there's different ones we can do, but really the rotate 180 would probably be the easiest, and once we did that, we could see they are congruent because it does map onto the other one, and we did follow congruence transformations.